heard Piers talk many times. He's somewhere between Mr. Wizard and a mad scientist, and always entertaining. Piers?
Whoops. Magic. We need the expert to produce my slide. I don't want to touch it. Here we are. Now, which one do I press? Or just click on the slide?
F5.
Oh, sorry. Okay, perfect. Hello? No. Can you hear me all right?
Yep.
Okay. Well, I'm Piers Corbyn from Weather Action Long Range Forecasters. I'm an astrophysicist and I do differential equations. And I like old computers, and those of you that received 10 emails of one email recently from me understand that. First of all, thanks very much to the Heartland Institute for inviting me here, and it's an honour to be here, and I would like to acknowledge various inspirational ideas and so forth I've received by looking at the works of Will Alexander, Sven Mark, Ken Ring, William Kinnemuth, and of course Willie Soon, who made a fantastic presentation earlier. Now today is March the 10th, you know that. On March the 10th, 1947, the great sunspot of 1947 was blazing, or unblazing if you like, in the centre of the solar disk. And a gale was blowing in a small town, Chippenham, Wiltshire, in England. And a 32-year-old electrical engineer, David B. Corbyn, was struggling through that gale, to see his wife, who was just in the process of giving birth. And when he arrived there, he found me, aged 0.0. I subsequently went to the same primary school in Chippenham, Wiltshire as Tim Ball, and now I'm here giving you two breakthroughs on Sun-Earth magnetic relations. Now, of course, you might say, well, what is this? Cause, effect, or association? And the reason why I'm telling you this is because we have to beware of confusing cause of an effect and association. Global warmers do it all the time. I mean, climate change is caused by climate change. But we have to be very careful because there's a lot of proxy data around and there are big dangers in confusion. We've got to think clearly. So what we're going to do now is have a look at, let's try this one. There we are. A quick summary. Now, some people might think I'm a bit hard on some people. What does and does not cause climate change? Now, one cross on this and you are out. Well, the way to determine these things is look at evidence, because we believe in evidence-based science, which was the second key point I was making. If you just look at 1975 to 2000 data, world data, any data, you could think, well, CO2 could have caused it, cosmic rays could have caused it, light variations in the sun could have caused it, or solar magnetic links could have caused it. And if you look over 100 or 1,000 or 10,000 years, you find from those, CO2 certainly could not have caused it. And if you look in the last 25,000 years, according to ICE core data, which is now somewhat questionable perhaps, you also conclude CO2 couldn't cause it. But you do also conclude that actually CO2 is generally driven by temperatures. Now there's other evidence of that, but that's what you conclude. If you move down one, you see light variations in the solar cycle. Well, there is a problem with saying these are the main drivers because they should vary with an 11-year signal, because the sun's light intensity varies with an 11-year signal. Now, in saying this, of course, you've got to be careful because there could be, well, there are some 11-year signals, but the dominant signal in world temperatures is 22 years. There are 11-year signals too, so what I'm saying is an oversimplification. Now, the same problem applies to cosmic rays because they are modulated by the size of the magnetic field of the sun. Whereas the ideas I'm putting forward is that the prime link between the sun and the Earth is due to magnetic connections, will of course produce a 22-year signal. Now, I'm not ruling out everything to do with cosmic rays. In fact, it distresses me a bit to even argue about it, because Nigel Calder's earlier books were tremendous in their praise for me and my gambling with William Hill and winning money from bookies for forecasting the weather. But there are some serious problems with the cosmic ray theory. It's certainly not the main thing. And the good thing about what I'm doing is using solar magnetic and even lunar modulations, which we're going to come to, is that we can actually make detailed forecasts. And many of you do know that last year in this hall I gave a forecast of a massive blizzard in the USA, and indeed in the middle of it, some of you maybe here phoned up and said, "My God, it's here." This year we've had about 60 extreme event forecasts since then, and most of them have come true. In fact, 87% of them have come true, and the percentage in the USA has been higher. And the biggest success has been the 3rd to 6th of February this year, where we said in that period there would be a massive Midwest blizzard, there would be super floods in Brazil, there would be a cyclone in Queensland, and there would be snow deluges in the UK. And they all happened. And the next forecast, in case I don't have time later, is to say 15th to 17th of March this year, there will be big snow and rain storms in central and northeast USA, and a tropical cyclone off northwest Australia. Okay, well, I won't go in much more to some of these things, because we've got to cover some quite important new ground. But just quickly to deal with the CO2 problems. The CO2 people know they have a problem, so that's why they've renamed global warming into climate change. And not only is there no evidence of the first link, namely CO2 causing global warming, there's neither evidence of their second link, namely that global warming is leading to more extreme events. Not so. All the major extreme events, well, not all of them, but a very large number of major extreme events that we can predict. And of course that greatly distresses the global warmers, who every time I make a severe prediction say, "Hey, it wasn't big enough," or "it was too big," or something, or "it was late," or "it was..." I mean, you know, they complained last year we were 3 days late with something from 300 days ahead. Well, are they 1% right in 24 hours? 15 minutes right in 24 hours? No, of course they're not. What rubbish, you know. They should apply their own standards to themselves. Now, we've seen this stuff from Joe Dalio. CO2 is going up, temperatures are now going down. But more significantly, of course, the last 4,000 years. Top graph is CO2, bottom one is temperatures, and they've been going down and are now rising a bit. Now the problem with the global warmers, as I said, is they then say CO2 is never risen so fast and so on, but all this stuff has been refuted, and I won't spend time on it. Now then, move to the issues of solar activity. You're familiar with this graph showing a close correlation between particles from the sun and world temperatures. And there is a correlation between carbon-14, galactic cosmic rays, solar activity or inverse galactic cosmic rays, etc., and temperatures over smooth times. But that doesn't prove that any one of them, carbon-14 or cosmic rays or solar activity, is causing. It's just there is an association. When you look in more detail, though, you can get some understanding. Now, what we need to look at is changes in carbon-14 are caused by changes in solar activity, which should lead to the 11-year signal. But if you're talking about, and geomagnetic activity will also be an 11-year signal, which is the particles coming from the sun. However, these particles are going to connect well or not with the Earth, depending on the sun's magnetic field. Now, I don't know if you can see this, but if you're in an odd sunspot cycle, especially between odd maximum, speak down here I think, especially between odd maximum and odd minimum, there is essentially good connections, magnetic connections, and the although these change on a daily and weekly basis, I add, but statistically there's more of this sort of thing, good connections. In the odd cycle, downward trend especially, it's mixed on the way up. And in the even cycle, on the downward trend, they're more bad connections. Okay. The first one will lead to flux transfer events, which is something that NASA have recently been unearthing. Now, if you look at temperatures averaged over 11 years and geomagnetic activity, you see this zigzag, and you see the first one on the left. You can see there are, well, there's a difference. They go up and down against each other. When you look on 22 years averaged, or the magnetic average, the correlation is astounding. And now, I first showed this graph in Moscow at the Russian Academy of Sciences in front of Sir John Houghton, no less. And I said to him, wouldn't that be nice, Sir John, if one of these was CO2 and the other was temperature? And he didn't say anything. Now, I would have thought he would have at least said yes. I mean, my goodness. But what is going on? Well, if you look at geomagnetic activity, first of all, that correlates better with anything than sunspot activity. Geomagnetic activity is about solar particles reaching the outside of the Earth's magnetic field, the magnetosphere, right? They come as a 10 or 11-year signal. But world temperatures, bottom graph, this is a power spectral density curve. Now, some of you are going to turn off at that point, but let's just say this just shows, if there's a peak, it means that's the main variability in that curve. The top peaks are, and then the lower peaks are lesser variabilities. In world temperatures, the main peak is the magnetic cycle of the sun, and you see it's exactly double, 10.7. Have you got one of those magic super-duper pointers? No, okay. And there is also something about 9.1, which actually could be 9.3 within the statistics of this. Ah, yeah. Fantastic. Which one do I press? That, whoa. There you are. That could be 9.3, and this one is twice that one. Okay, that's the magnetic effect modulating whatever comes to the magnetosphere. And I want to draw your attention to something arrowed here, which could be about 8.5, for example. As a first idea, what I'm saying is, well, possibly, if you go back to that, the two biggest signals in this one are the, well, apart from that, but this is a low frequency, so the errors could be large in that. But these two are certainly there. If you look at the beats between these two, now, this thing, astoundingly, is the periodicity of the nodal crossings of the moon. Okay? We'll come to, could this mean anything in a minute, but there you are. If you look at the beats between this and this, well, let's just first of all look at even the 18.6-year full rotation of the solar lunar nodes, and we find, well, if you want to see when they last coincided, 6 times 22 is 132, see? 7 times 19 is 133. So roughly that time ago, from 2007 or 8, we would find these years. Well, these were the years in England where there were floods. We wrote to Gordon Brown about this, and we also wrote to the IPCC about a number of things. And I can tell you the UN and IPCC haven't replied, but Gordon Brown has. And we asked for evidence of global warming, and his sidekick said, write to the IPCC. So we're going to write again to the IPCC. He said, well, Gordon Brown asked us to ask you. Now, please give us the evidence. Okay. Is there any evidence in more detail, apart from these floods that time ago, for this sort of modulation? Well, there is. And here's a graph which Joe Dalio drew up and put these zigzags on after various email discussions with myself. And you see this is the US data, because nothing is true unless it's true in America, so that's why this was chosen. And there's a 60-year periodicity. which actually is the beat period between the numbers I referred to. Now, you'll like this bit. If we look at 3-year moving trends, now looking at world temperatures, because we have to look at world temperatures, there's the peaks marked, and now here's the magic bit. 5-year moving averages. Now, if what I've said is true, best links between Sun and the Earth, odd cycle, maximum declining, especially the maximum, and questions of do the lunar nodes line up with the Sun's equator? Because we say, well, we found in our long-range forecasting what happens on the equator of the Sun is very, very, very important. Okay? Now, these line-ups occur when you have a solar eclipse or a lunar eclipse at or close to December the 5th or 6th, or the other 6 months later, okay? Because that is when the, Jesus, 5 minutes. That is when the moon, on the 5th of December, the Earth is in the same plane as the solar equator, okay? Now, where we are in 2001, 1 year after solar maximum, which may be the best magnetic connections, probably is, we had on December the 4th or so, we had a solar eclipse. The next best hit, solar cycle 17, and the next best hit, 11. And here we have these peaks. And you have sub-peaks where the hit isn't so good, or where there's no hit, you have no peaks. I think you might agree there's something going on there. I mean, and of course, don't get hung up with solar eclipses. They're a proxy for a whole lot of other things, lunar eclipses, different levels, latitudes of the moon relative to the Earth's orbit, and so forth. But something is going on, and we'll leave that one. Quick look at what might be going on. Solar wind, lots of things coming out of it, coronal mass ejections, flux transfer events. This bit gives geomagnetic activity. That bit gives you the 22-year modulation. Play around with these numbers. We can discuss this later. But you get beats of 2R, that's the lunar nodes, minus 2 times the magnetic Hale cycle of the Sun, and you get 59 years, or 118 years, for longer ones. So the figures come out, right? Now this you will like, so I'll have to speak fast. If you go back to that graph, you see there's something interesting here. Lots and lots of eclipses. Now why the hell are they doing there? Well, there's something to do with the the rotations of the perigee of the moon, so that, the perigee of the moon, so that the sort of preferred timings. Well, the perigee of the moon rotation actually turned up, if you recall, in that PSD, 8.5 years. The lunar nodes turns up. There's 11 years there, there's 22 years. Now, the next bit, this is real magic. If there is this connection between the Sun and the Earth and the Moon, then there's going to be an exchange of angular momentum. Something subtle, very subtle, is going on. Might be very small, but it's been going on not for millions, but for billions of years. So this would actually make some effect. And what do we have here? The magnetic rotation period of the Sun is pretty well exactly the same as the nodal crossing period, ratio 1.0. Now, this happens only one other place in the solar system of having a similar thing, where you have similar ratio, sort of comparable masses between the planet and the moon, and it's Pluto and Charon, ratio 4.0. So I think there's something going on there which needs further investigation. Or as William Loon said, we certainly haven't closed the book on this matter. Now, almost last thing. How the hell can solar particles and events change the weather? Well, we know they can because we've predicted it, but leaving aside details, what about average temperatures? Now, this is a calculation, which isn't that difficult. It's very simple differential equations. The Earth is radiating heat all the time. It radiates it most where it's hottest, from the equator, T to the fourth, absolute temperature to the fourth. If you remove a bit of heat from the equator towards the poles, the equator cools and the polar regions warm up. The reduction in radiation from the equatorial regions is larger than the increase of radiation from the polar regions, because of the T to the fourth is more effective. You can work therefore out you will have to get a slight warming of the world because it can't get rid of its heat so quickly and it's receiving the same amount of light. There's the calculation. And if the poleward transport changes by 1% of the total radiative flux, you can get out a 0.1 degree here if this is about 15. I would submit that this is something that has to be looked at and is seriously important. Last thing, solar, without going into a lot of details, ultraviolet plays a vital role in the stratosphere. On the 6th to 8th of January, but on the 22nd to 23rd of January, see the thing at the bottom just mentioned something else. 22nd to 23rd of January this year, there was a sudden stratospheric warming, a very sudden, very warm stratospheric warming, which coincided with one of our solar weather impact periods, which we said would be the most ferocious one, the winter. And there were some hurricane-force winds in Spain and so on, which killed some people. But the significant thing here is this stratospheric warming, where the temperature went from -80 to -40, i.e. 20 degrees C, as a percentage of 200 degrees absolute. That's 10%, 20%. Where are we? -80 to -40. 40 over 200 is 20%. Well, that is a 20% increase in pressure in the stratosphere. Well, this is going to move something in the stratosphere and also move things downwards. And we know after that there was chaos in the jet stream, and we were able to forecast a lot of extreme events, weather events, which happened. So I just want to end finally with forecast for world temperatures. Solar lunar stuff would give you 20 to 30, 32 as a minimum. That's that 60-year cycle. The magnetic hail cycle is the even peak at solar cycle 24 plus 2 years. You find there actually temperatures are going to be negatively correlated with geomagnetic activity. That's what happens in even cycles. So solar activity actually isn't going to be such a big deal in the coming cycle. Sorry to say that, even though although the details will be very, very, very important. The very important thing is going to be the next odd cycle and what's going to happen around 2024. So our conclusion is there will be general cooling to 2030 and probably or possibly beyond, reaching 1970 levels, and there is a possibility of getting much colder by then or by 2040 if there's going to be an ongoing very low level of solar activity, which there could well be and needs more work, especially in the coming odd cycle, i.e. after 11 years after this even cycle we're just beginning. Thank you.
Thank you, Piers.